I'm about to make a mixture here. I've got some water, just pure water, deionized water, and I'm putting it in a test tube. And next I'm going to take an alcohol. No, actually before I do that, I'm going to put in a little food coloring just to mark the water so that it's easier to tell where it is, because I'm mixing it together with another liquid that's also colorless like water. So I'm just coloring the water a little bit. Now I'm going to put ethyl alcohol, or ethanol, in the test tube. And you can see at first it looks like that they're not quite mixed together, but if I shake it just a couple of times, it becomes like one continuous looking substance. Let's think about what's happening here at the particle level. If we could look with submicroscopic vision and see at the particle level a tiny sample of water from the water beaker before the mixture occurred, we'd see what we'd expect for a liquid. The particles are close together because liquids are compact, and the particles don't show any structure because liquids don't have a structure like solids do. Ethanol, same story, compact and unstructured. It's also a liquid. It's a different kind of particle, however. When we mixed these two together, we were not able to see any longer where the water was and where the ethanol was. That would imply that if you could look at the submicroscopic level and see the particles, you would find that they're mixed together so finely that it would be impossible to tell where ethanol and water were. I'm going to make another mixture. I have deionized water again. I'm starting out with water. I'm going to put some in the bottom of a test tube. And like I did in the previous mixture, I'm going to put a marker in the water. I'm just going to put a little blue food coloring so we can keep track of where the water is in the mixture. Next, I'm going to add some mineral oil. It's another liquid, you can see. There appear to be two distinct layers. I'll shake them up like I did the alcohol and water. And now it appears that there still are kind of two separate layers. I'm going to wait a while to see what happens. I'm speeding it up here so that you don't have to wait as long as I did. And even after waiting, in fact more after waiting, it seems that there are two distinct layers for the different substances. So the oil and the water make two different layers. Again, let's take a particle look at what's happening here. We've already seen that water is a liquid. It's got particles that are compact and unstructured. The oil is also a liquid, so it's going to have particles that are compact and unstructured. They're different substances, so the particles would be different types of particles. However, this time in the mixture, when we put the two together, they did not mix together very finely. They refused to mix together. So it would make sense that if we looked at the two layers, they would each look like they did before they were mixed. Only at the boundary would we be able to see both types of particles, and they would still be separated from each other. So for some reason, this type of mixture does not mix as finely as the other type with like ethanol and water did. I'm about to make another mixture, so I'm getting another test tube, and I'm going to add some more water, distilled water, deionized water. So this is just pure water going into the test tube here. Next, I'm going to grab some sand. So this is just a fine white sand, like you'd find on a beach, only it's really sifted. There's no impurities in it. It's just really nice clean sand. Just grab a spoon, and I'm just going to scoop out some sand and put it in my test tube to make a mixture. Now I'm going to cover the top with my thumb and shake it up, and I'm going to speed this process up. Even after a considerable amount of shaking, you can see it still looks like there's two separate layers. The sand and the water have not mixed into each other very finely. Shake it some more. Again, this is sped up. Nope. Still two layers. Let's take a look at what this would be like at the particle level. We've already seen water is a liquid, so that means compact, unstructured arrangement of the particles. Sand is a solid, so that means we do have structure. And if you think about sand, it's not just one big continuous structure. It's made up of little tiny structures of particles. So this diagram here represents little arrangements that are all rigid, structured, compact, but they're all little particles made of particles, kind of. When we mixed the two together, we did not find that they made a good mixture. The sand stayed at the bottom and the water stayed at the top. So if we were to look at the water, it would just look like water. If we were to look in the interior of the sand, it would be wet, so that means that some water particles would probably be in between the small sand particles, but the sand particles still maintain their structure because they still behave as a solid does. So this is a little bit like the oil and water mixture because we don't get complete mixing. You can still tell that it's made of two parts. I'm going to make another mixture. Again, I'm going to start out with water in the bottom of my test tube. Like in the previous example, I'm going to add a solid. So I've got some sugar here. Take a spoonful of sugar and put this in my test tube to create a mixture. I'm shaking this up now to mix it. I'm going to speed this up. I shake it for quite a long time here. You don't have to watch all the shaking at regular speed. When it's all done, you can see that there actually seems to be more like just one layer now. The sugar seems to have disappeared. Again, let's examine what's happening at the particle level. We've seen water in all of our mixtures. That's just a compact, unstructured arrangement of particles that's typical of liquids. The sugar is arranged like the sand. There are particles made of particles, and so there are these larger particles that we can actually see with our naked eye, little grains of sugar that are made up of smaller particles of sugar. When we mix the two together, unlike the water and sand mixture, the sugar particles seem to disappear into the water. They seem to make a mixture that's kind of like the water and ethanol mixture, where the particles are mixed together so finely that you can't tell where each is. So if we could take a sample of our mixture of water and sugar and look at that close up so that we could see the particles, just like the water and ethanol, we would see individual sugar particles spread out throughout the water in such a fine mixture that we couldn't tell them apart. There seems to be something about the sugar particles that lets them break up so that they can mix in with the water that's different than the sand particles, which were unable to break up and mix into the water. Just for fun, I decided to try another mixture. Now I'm taking ethyl alcohol, which we mixed with water earlier, and I'm going to put some of that in my test tube. Then I'm going to take some sugar and I'm going to add that to the test tube and make a mixture of ethanol and sugar to see how that behaves. And again, I'm going to shake it up to give it a good chance to make a mixture, and I'll speed that process up because I shake it for quite a long time. Doesn't look like it's mixing. And after quite a bit of shaking, when I take a look at the end, it doesn't look like it dissolved and disappeared into the water, into the ethanol like it did the water. So it depends on the substance being mixed, both of the substances being mixed. Make another mixture. Now I'm going to use two solids. I'm going to start out with some sugar in my test tube. And then I'm going to use some of the sand that we used earlier, this fine white sand, and put a little bit of that in the test tube as well. Two separate layers. I'll mix them up. Now it's harder to tell that there's two layers. It looks like one. Let's take a look at the particle level view of this mixture that we just made. Sugar particles and sand particles are particles of particles, like we've seen before. Both of them are. When we mix them together, we can sort of get the particles of particles to mix together, the big size particles to mix together. And to our eye, we can tell that they're made of particles, but we can't really tell where the sugar and where the sand is because they are pretty similar. If we used a magnifying glass, we might be able to tell sugar from sand, but to our naked eye, it's pretty hard to tell if it's all the same or different. Looking at the particle level of our mixture, we would just see the individual granules, the particles made of particles, mixed together with each other as best they could be mixed. There's a lot of empty space in between, so it would be possible to wet this mixture by adding a little water or some liquid where the particles could spread between the larger granules. Let's examine all the mixtures that we've made and find a way to sort them out. This is the ethanol and water mixture. This looks the same everywhere. You can't tell where the ethanol is or the food coloring or the water. This is an example of a kind of a mixture that we call a homogeneous mixture. It comes from two word parts, homo, which means same, and gen, which means form. So these things are the same form throughout. They look the same everywhere you look. So it wouldn't matter where you took a sample from that test tube, it would be pretty much the same. And you can't tell by the naked eye that it's not a pure substance. This is our oil and water mixture. You can clearly tell that there's two things in there with your naked eye. You don't have to know the history of that test tube to know that that is not just one thing, that that's a mixture. That's an example of what we call a heterogeneous mixture. So a hetero word part means different. So these means that there are different forms throughout the mixture. That's what that name means. So that's the two main ways that we can sort out mixtures, heterogeneous and homogeneous. Let's look at some other examples that we made. This is the sugar in water mixture. It's also homogeneous because you can't tell with your naked eye that there's sugar in there if you didn't know ahead of time. This is the sugar in ethanol, I believe. That's heterogeneous. Here's the sand in water. That's heterogeneous. You can tell by your eye that there's more than one thing in there. This is the sand in the sugar. It's a tough call. Some ways it looks like it's all one thing, but if you look more closely, you could tell it's a mixture.